So after clicking the link to the skate park activity, we're gonna end up on this landing page with 3 different games to learn more about how energy works and transfer of energy, along with some concepts like gravity, mass, friction, and the transfer of energy. So these are some of the key concepts that we discussed in the beginning of the slideshow, and we'll explore them more here. So when we first open up the game, we're at this, for the introduction, we have this simple U ramp, and this setup has no friction. So we can drag the skateboarder and place them, and then press play to see how they react. Notice how when the skateboarder is moving on the ramp, they're reaching the same height on each side. And we can verify that by clicking the grid box, and we can see that they come around a little bit above 4 and end a little bit above 4. So this is one property when there's no friction. And also, when we click on the pie chart graph, we can see the kinetic energy and potential energy like transfer. So if we were to pause here at the bottom, it's entirely kinetic energy. There's no more potential energy. And this is because it's used up all the energy from the potential energy is what's the energy from like sitting that's waiting, which is due to height off the ground. But here we're at height 0, so it's all kinetic energy now. It's all in motion. So this is when the skater goes the fastest, and we can also see that with the speed graph, which I'll show in a minute. But right here at the top, we can see that it's entirely potential energy. The skateboarder is not moving at this point, and so it's all potential and no kinetic. And also we notice that all of the energy is transferred between these two. The entire circle stays full. So that's also another important thing to note. So when we look at the speed, it's now 0 speed. But as we go to the bottom, it peaks, and then it peaks somewhere around here. And then it'll go back down to 0 on each end. So that's how it looks like with no friction. And we can also see this bar graph, and it's another way. It's very similar to the way the pie chart shows this information. Now you can try out some of these other shaped skate courses and learn a bit more about, and just explore how like the energy transfers, but more or less the key concept should stay the same. Now if we go to the friction activity, which you can click here at the bottom for, we can see how the skateboarder reacts in a situation where there is friction. So we have the same setup with the shape of the parabola, or the shape of the skate rink, and here. So if we'll place them somewhere up here and let go, we can add the grid line so we can see the information, and we can also show speed. So notice how this time it reaches the bottom, and all of the potential energy that was blue at the top now transfers to mostly kinetic energy, but a little bit of thermal energy. So this heat energy is basically a result of the wheels rubbing against the pavement or like whatever ramp, and it causes some energy to be lost to heat. So this slows the skateboarder down. So they're not actually able to go as fast as they are in the previous exercise, which means they're not going to make it as high up in the ramp. So we can notice that here when they make it a little bit less than 4 versus they started above 4. And now it also has less potential energy. So none of the energy is created or destroyed like we learned, but it is now transferred into heat energy, which isn't visible in terms of speed. And so we can see that each time the skateboarder goes up and down, they go up a little bit less. And this is more like real life. So if you were to skateboard like this on a ramp, you wouldn't be able to go forever, like in the previous example. So this is how it's a little bit different. Now if we go to playground, we can start this over real quick, and we can now build our own shape. So you can drag these red dots to explore like different shapes. So if we make something like more exciting, like this roller coaster looking ramp, and we can keep connecting these as much as we want. So let's try something like this. And there's 2 different versions. This one allows you to jump off of the ramp, like kind of like a like you're not like you're not glued to it, but this one keeps you stuck to it. And I can show you the difference. So I'll start them right here and let go. So it makes it over the ramp, and it doesn't fly off the ramp like you might in some video games. If you were to start again. So here, we're gonna try the second example now, where you can fly off of the ramp if you have too much energy. So you can see they hopped up a little bit and they like kind of flew. And this is like more like Snowline in the sense that like, you know, you have to like think about like the actual arc of a ramp, unlike the previous example. So like in a roller coaster, like you might fly off if you don't have the right shape. So I guess this is more similar to that. And so it's a little bit more exciting to try out and play around with. So just try like different things and have fun.